Okay, we are recording. So with that,
Everybody mute your microphones.
okay, yes, thank you very much for that reminder. And go ahead, Kevin.
Okay, well, I appreciate the opportunity to present. My name is Kevin Zanjani. I'm with Bioenno Power. I just want to make sure I can share my screen. Do I have permission on that? Okay, make sure.
Let me spotlight you.
Okay. Can you see the screen?
Yes.
Okay,
Yep.
Very good. So yeah, my name is Kevin Zanjani. I am with Bioenno Power. We're a manufacturer of lithium iron phosphate batteries. Some of you may have heard about our company. This presentation is going to be about lithium iron phosphate batteries. And so we're going to be discussing kind of the a bit of a background about this technology, as well as how it can be used for ham radio and solar applications. Our company is based in Santa Ana, California, 3657 West McFadden Avenue. We're located near Disneyland, so if you had a chance to come out here to visit, we're just south of Disneyland, about 15 minutes to the south. Website is up there, bioennopower.com, as well as phone numbers. So if you have any questions, you can ask us at the end of the presentation. We're gonna let the questions occur. I'm gonna ask them at the end of the presentation just to make it easier because of the format that we have here. So our company was founded in 2010. We're a manufacturer of lithium iron phosphate batteries. So these are batteries that look something like this. They have built-in cylindrical cells. They look something like this that are used to build up these batteries. These batteries are different than lead acid batteries that you probably use for ham radio. This is a new type of technology that offers 2,000 to 3,000 charge cycles. There's a circuit board built into every single battery. They have power pole connectors attached to the battery that plug into your radio equipment, as well as a charge plug as well for charging up the battery. Our facilities are located here in Santa Ana, California. Implemented various standards, as well as we're offering a world-class technology, after sales service, warranty, and we have customers worldwide. In terms of the customers that we're dealing with, some of our customers include those federal agencies, including the DEA. So we do business with DEA. They're using some of our power pack products. I'm going to be pulling different products that we're going to show for show and tell. So looks something like this. These are some of the power packs that we do offer. They're using it for powering various tablets out in the field. So tablets and computers out in the field. They're also involved with powering various types of communications equipment as well. DHS is another customer of ours. They use, you're probably familiar with it, is a Raspberry Pi. So not apple pie. It's, if you're not familiar with a Raspberry Pi, it's a little computer that has a built-in CPU, memory. It has the ability to connect to a lot of equipment. You can use it to control equipment as well. So they're using some of our larger batteries. Something like this is our 20 amp hour lithium iron phosphate battery. It's used for powering various types of Raspberry Pi equipment out there in the field for DHS. DOL, Department of Labor. You might be wondering, why does the Department of Labor use batteries, federal agency like that? Well, they actually handle a lot of the mining industry within the US. So out in West Virginia, DOL is using some of our larger 100 amp hour lithium iron phosphate batteries for powering various equipments in mines, because the lead acid batteries, they can't keep up. They've had to change those batteries out every year or so, and they wanted something that can last 2,000 to 3,000 cycles. So about a 7 to 10 year service life versus a seal lead acid or AGM battery that you're familiar with. The Forest Service. So why would a Forest Service be using batteries? It's a very interesting application for the Forest Service. So your federal tax dollars, they go to scientists out in the fields for effectively what it is. It's a very large capacitor strapped onto their back. It's a very interesting application of batteries. I mean, why is a scientist wearing a capacitor on their back? Well, these are scientists that are studying species of fish. They're wearing this fairly large capacitor on the back, using about 6 to 12 amp hour battery to charge up this capacitor, they stick a fairly long rod into fresh water. They send a high electrical current down into the fresh water, and the fish pop out of the water. They measure the weight, the length, just to see how healthy the fish are. And out where you're at, there's a lot of invasive species of fish that are invading the rivers and lakes out there. And so the Forest Service is analyzing these species of fish out there. So it's an interesting application of batteries. Now, this is something called electrofishing. You go on YouTube, you can take a look at it. Something that you do need a permit. You need to be a federal scientist, I think state scientists as well, qualify for that. But it's not something that you can quickly go and buy. The equipment's sold by a company called ETS Electrofishing out in Waukesha, Wisconsin. Continue to do business with various universities, MIT and Naval Academy as well. They've implemented a lot of curriculum changes studying batteries, renewable energy, solar products as well, solar equipment that's used out in the field. So that's been implemented in the recent years at the university level. Up in Canada, up near Manitoba, Saskatchewan, Alberta, we do business with companies that are doing oil and gas exploration up there. Despite with all the changes with renewables, they actually use quite a bit of batteries in the oil and gas industry, particularly to power equipment that are used for finding these new sources of oil and gas. And so there's a company called Nanometrics in Ottawa, and we continue to do business with them. They work with a lot of companies up in Canada for oil and gas exploration. The reason they're using the lithium iron phosphate batteries is actually the cold temperature performance. Lead acid batteries can't keep up at very cold temperatures, about minus 30 Celsius, minus 20 Celsius. And so these batteries, they actually hold up quite well, having about over 85% usable capacity versus a lead acid battery, which only about 50% is usable. We're going to talk about more about that later in the presentation. So lithium iron phosphate batteries, several acronyms, LFP, you're going to hear lithium iron phosphate, lithium ferrous phosphate, LiFePO, LiFe. So when we use this acronym, we use this word interchangeably, we're talking about the exact same chemistry. It's now considered to be a state-of-the-art battery chemistry, has a very high degree of thermal and chemical stability because you have a very tight iron phosphate bond. About 2,000 to 3,000 charge cycles. So we introduced the batteries around 2012. We were founded in 2010. We introduced them in 2012. We still have the original batteries out there. It's been about 8 years. We go back to those original OEM customers. We're asking, do you need to change out the batteries? And they say, no, it's still holding up after those several years. Now we want to distinguish this chemistry for something that's used in your phone. So in your phone, like particularly like, for example, this iPhone here, this is a polymer battery, lithium ion polymer, and it's known as LiPo batteries. These are not lithium iron phosphate batteries that's in your phone or laptops. These last maybe about 800 cycles or so, and they use what they call a polymer stack because they can be molded. It's different than this type of chemistry that's packaged in cylindrical cells, okay? So this particular chemistry is packaged in cylindrical cells, something akin to what's in electric vehicles. It's much more robust in terms of its packaging as well as performance and service life and cycle life. So it's distinguished from batteries that are used in your phone. So what's the difference between, let's compare a lithium iron phosphate battery to lead acid batteries. So all of you've used lead acid batteries. It's in your car. You've probably used a deep cycle lead acid battery for radio, and you found that it's, the problem with lead acid batteries, you've probably seen what happened, after they go bad, they sulfate, the acid comes out. I had a problem with my starter battery in my car a couple of years ago. That went bad. The sulfuric acid ate the metal terminals. It actually ate my harness on my car. It was a big mess. This is a different type of chemistry. We're not dealing with any sulfuric acid. We're not dealing with any lead. So non-toxic from that standpoint, and a very tight chemical bond. Lead acid batteries, they're quite heavy. This is about a third the weight of a lead acid battery. So this is a 20 amp hour battery. Weighs about 5.5 to 6 pounds, comparably a lead acid battery about 18 to 20 pounds in that regards. SLA batteries, maybe about 200 to 300 charge cycles. This is 2,000 to 3,000. So that's a huge difference in terms of cycle life versus a lead acid battery. So as we're talking about in terms of longevity and performance, we're seeing already in year 8 customers that are still using the original batteries in terms of that performance. Some of you may have used a lead acid battery for running ham radio equipment or other types of electronics equipment. You've left the battery, you left your equipment turned on, and the battery's voltage keeps dropping. You get to a voltage where you can't recharge it. You killed the lead acid battery, and it's very hard to revive it. There's no notion of any kind of protection circuitry inside the battery. Every single one of our lithium iron phosphate batteries, they have a circuit board built in. This circuit board provides a protection against overcharge, over discharge, over current, under voltage, over voltage, and thermal protection. So that's built into every single battery, which is really important if you're running your equipment. Let's say you leave your equipment turned on, the circuit board will shut off the output at around 10 volts. So the battery's protected, but from a user standpoint, you'll see a battery that's turned off. So all of the cells that are used inside the lithium iron phosphate battery, they're sitting at voltage, but the output's been turned off. Another important aspect is the fact that with a lead acid battery, there's something known as the Puchert's effect, where only about 50% of the battery's capacity, lead acid batteries, is usable if you were to pull what's called a 1C discharge. So for example, if I was pulling, for example, on a lead acid battery, a 20 amp hour battery, or 12, I was pulling 20 amps out of it, only 50% usable. But with a lithium battery, I can get nearly 100% usable capacity out of the battery. That's a big difference. That means I can use a fairly small lithium battery, lithium iron phosphate battery, in order to run equipment. So for example, this 20 amp hour battery here could run a 100-watt radio for about 7 to 10 hours, 20% transmit, 80% receive on HF sideband. And it's a pretty lightweight battery for running a 100-watt radio at full power output. We'll talk more about that later in the presentation. With respect to memory effect, so there is no memory effect with this particular chemistry. We can charge at 20%, 25%, 50%, or 75%. So you can use it for both what's called cyclic as well as standby applications. So cyclic means you charge up the battery, you run the equipment until the battery's output shuts off, and then you recharge it. Standby is like a UPS or telecom application because we don't have that memory effect. We can partial cycle the battery, so we're not experiencing that degradation. And a half cycle, a partial cycle doesn't count as a full cycle. So that's a big advantage, partial cycling, and the fact that we're not dealing with this memory effect that you see on other chemistries, like nickel metal hydride and other chemistries out there on the market, older chemistries. Few percent per year in terms of self-discharge. That's also a very big advantage over a lead acid battery, which if you're to let it sit, you have a lot of issues with a lead acid battery. So on the left-hand side here, this is an example of a 12 amp hour battery. Only about 50% usable if you were to pull about 12 amps out of it. Lithium iron phosphate battery, we're getting nearly 100% usable capacity, which means we can use a smaller battery for the application. We get a lot of questions about the circuit board inside the battery. What is this protection circuit module? What does it do? So it does several functions. It balances and equalizes the cells inside the battery, as well as it provides over voltage, over current, over discharge, as well as short circuit protections. That's all built into that circuit board on the battery. So it's not just cells. Some manufacturers, they may just provide cells that are connected. There's a circuitry integrated in there as well, so that you have those protections built in. This is an example of a typical battery spec sheet that we provide with the batteries. So what's important here to look at is the internal impedance, less than 100 milliohms. And what's important about that is the fact that as the battery ages, we don't see that internal resistance increasing like a lead acid battery. It tends to stay quite stable across the age of the battery. That means you don't get that voltage drop across that internal resistance as the battery ages, unlike a lead acid battery, which you'll see as you load the battery quite a bit. We provide you with any kind of parameters that you need if you wanted to build your own charging system as well. So that's available. This is very interesting. This is the discharge curve. This is a 12 volt, 20 amp hour battery. This is the one right here. If what you'll notice on this curve is it's quite flat across 95% depth of discharge. So if I was to pull power out of this battery, you'll notice it stays above that 13 volt range, and then it drops off around 10 volts. There's the cutoff, which the circuit board is shutting off that output. So all of that capacity is available, meaning again, we can use the very small battery to replace something that's quite large, even up to 100 watt transmission. This is also a curve that shows you the usable capacity versus temperature. So if you take a look on the left-hand side, you'll notice here for an AGM, AGM means it's another word for an absorbed glass mat battery. It's a sealed lead acid battery. If you were to pull a 1C discharge on an AGM battery, meaning if you were to pull, for example, if you had a 12 volt, 20 amp hour battery, you pull 20 amps out of about 30% is usable at about -20 Celsius. It's about 14 Fahrenheit. If you are using a lithium iron phosphate, it's more than 80% usable. So this is a big advantage. We're seeing that up in the northern states as well, up in Canada as well, where this performance starts to be pretty dramatic improvements at the really cold temperatures. On the high end, it's also near 100% available as well. The rates for AGM, though, at very high temperatures. So that's really important, is that available capacity versus temperature. We get some questions about calculating the runtime based on the power. So if you remember from the test, we've got your power, voltage times the current, we've got our watts, 12 volt, 12 amp hour battery, it's about 144 watt hours. So if I was to pull 10 watts out of the battery, about 14 hours in terms of the runtime. But with radio, it's a little different. Okay, so with radio, we transmit at a higher power, we receive at a lower power. Transmit at a higher power, receive at a lower power. And we have what's called a weighted average power. So if I'm doing a QRP transmission, if I'm using a QRP radio, so for HF, radios 817, 818, Elecraft KX2, KX3, or the new ICOM 705, a 12 volt, 12 amp hour battery would get me something about a 40-hour runtime. And that's pretty significant for a battery that weighs maybe about 3 pounds. For a 100 watt transmission, again, this would be, for example, 857, ICOM 7300, any 100 watt radios, 891, 991 from Yaesu. Something like this would get you about 10 to 11 hours of runtime for an HF 20% transmit, 80% receive transmission. So there's quite a bit of usable power out of a lithium iron phosphate battery versus a lead acid battery. And so we're going to use this later in the presentation to review in terms of usable capacity. So we're going to switch gears right now. We're going to talk about some of the projects some of our customers are doing with the batteries. This is Michael Jones, W6GYC. He's out here in Santa Clarita. He's built a Go box with the battery. He's got the 20 amp hour battery inside of a suitcase with a solar controller. So solar controller looks something like this. And he's built a setup where you can charge the battery using a solar panel, a solar controller, as well as the battery. Now, this controller is required in order to charge up the batteries using solar. The reason being is the solar panel's voltage ends up being quite high, and you need a controller in order to regulate that voltage in order to charge up the batteries. We'll show some more information about that later as we go through the presentation. This is out in Panama City, Florida, N4KGL at the top left, doing field day down there. He's got the Elecraft KX3 radio. It's got a mosquito net down in Florida. If you've been down there in the summer for field day, you got to have a mosquito net. Slim Jim antenna. He's got one of our 15 amp hour batteries. This is really cool. This is Norwegian station, amateur radio station LA9XGA. This is Summits on the Air SOTA. So I'm sure you may have heard about Summits on the Air. It's a competition where you go to these mountaintops to go activate these sites. You get some points during this competition. I'm going to read you what he wrote. This SOTA hike started from my home Ixis Ranch at 0600 UTC, and it took me around 3 hours to get to the summit. The weather today was almost unbelievable with minus 10 degrees and a clear blue sky, and the view from the summit almost indescribable. On this activation, I was using my Elecraft KX3 with 5 to 10 watts of output, 2 Bioenno Power lithium iron phosphate, 12 volt, 8 amp hour batteries, and a buddy stick multi-band vertical antenna. I made a total of 153 QSOs on this remote summit activation. 153 QSOs, that's a lot of QSOs. And it just gives you an idea of terms of the temperature performance, even up in Norway over there. You gotta have your a tent, some skis when you're over there, and at nighttime you build a fire. So it's an interesting application of batteries. I know many of you are interested in solar for powering the batteries while operating. So you can operate your radio equipment using a battery. We talked about this solar controller, and then this controller is used to regulate the voltage from the solar panel. So what you see there is a 60 watt solar panel. This is a foldable solar panel that's also available. This is a 28 watt solar panel. It provides about 1 to 1.5 amps of charge current, and the one that's shown on the screen is what's called a rigid solar panel. That's 60 watts, or you could chain these panels together. So these panels have the ability to be chained together for expanding the power. So you can start with, let's say, for example, if you want to do a portable operation at 28 watts, then you can use larger panels in order to scale up. Now over there in Michigan, you need a little bit more larger panels to compensate for the overcast days. So we typically suggest something a little bit larger. For example, at least maybe 60 watts to about 120 watts for operating solar over there. But you can still do it throughout the year. So how many watts for the solar panel? So it really depends on the battery. So for example, 12 volt, 12 amp hour battery, 144 watt hours, 60 watt panel would charge it in about 2 hours, assuming you have full sunlight hitting the panel to generate the required power in order to charge it up. So it's pretty proportional with respect to the size of the battery. Do I really need a solar charge controller? I just want to hook it up directly to the battery. So again, it's a must because the voltage from the solar panel actually ranges somewhere between 15 to 22 volts. And so you regulate that voltage in order to charge the battery so that the correct charge current's going in. That is required for the solar controller. This is a very common question that we get. Do I need a special charger for the batteries? So the battery wants to see what's known as a constant voltage current limited power supply. It can be either a linear or a switch mode supply. The overcharge and overvoltage protection, that's all built into the battery. So you don't need a special balancing charger. So if you're familiar with quadcopters or radio controlled cars, they use the polymer batteries. There's a balance connector, and you need a special fancy balancing charger. You don't need any of that. You can apply a voltage anywhere between 13.8 to 15 volts, and then current limit the input from the supply in order to charge the battery. Now there's a couple options. We provide with the batteries a power supply that looks something like this. Okay, so this is just a switching supply. It's very simple. Puts out the voltage and the charge current, and we pair it up with the purchase of the batteries. But you do have other options. Okay, so if you guys are using a benchtop supply, there is a West Mountain radio product. This is called Epic Power Gate. You can attach the power supply over here, and then you can plug the battery there. And this product also has the ability to set with these jumpers over here. You can set the chemistry for lithium, and then you can set the amperage as well as control it through a USB interface as well. Over here, you can attach it to a computer and read and set the charge current. Also read out the charge current from a solar panel as well. So you can use a common charging equipment in order to charge the batteries. It's a very common question that we receive. What's the charging voltage? So it charges anywhere between 13.8 volts to 15 volts. And then what's the open circuit voltage after charging? So it's about 13.2 to 13.5 volts. So this voltage matches up with the radio equipment quite well, which wants to see something around 13.8 plus or minus 15%. So you don't need a battery booster with this particular type of battery chemistry. You just plug it directly into the equipment and you can go ahead and use it. So it's one less piece of equipment that you need out there in the field. What size of battery do I need? And how do I know? So we want to look at our total power consumption and desired runtime. Now for a continuous power consumption, if I was using 50 watts continuous, 12 amp hour battery, about 3 hours, 20 amp hour battery, 5 hours, 40, about 10 hours, 100 amp hour, 24 hours. Now that's for continuous power. In radio, we have that weighted average. Remember we mentioned earlier, this is very critical for radio. We transmit at a higher power, receive at a lower power. So we can use a smaller battery. And there's a chart that we have, it's located on our website. This is a snapshot of the chart here. It depends on the transmit power that you're at. So for example, for QRP, HF transmission, a 6 amp hour battery, something like this, about 12 hours of runtime. If we're going to, let's say 50 watt VHF, UHF, we're doing work on the repeater, maybe simplex, DMR is between like around 20 watts. This is we have a 12 amp hour battery, puts about 10 hours of runtime. The 9 amp hour battery, somewhere around that range, 12 hours or so on 20 watts, and then 50 watts about 7 hours or so. Now, if we go to 100 watt transmission, we got to use something a little bit larger. We go to the 20 amp hour battery. This is quite popular. This is about 10 hours of runtime at a 100 watt transmission. So it really depends on what you're looking at in terms of your power levels, what kind of transmission you're doing. We can answer questions about that later in the presentation. I'm going to shift gears right now. I'm going to talk about some of our commercial work. Some of the work that we're doing includes Southern California Gas Company and Sempra here in the Los Angeles area. So natural gas out here is typically stored in these massive underground reservoirs in order to buffer for demands. So our state law here requires extensive monitoring for any leaks from these reservoirs. And this is an example of a unit that was installed, what we call a data collection unit. And what you see here is the cylinder right here. This measures the release of any kind of gas. So it measures in terms of the parts per million of gas that might be released. And then this is the data collection unit. It has a built-in ability to measure in terms of that release of the gas, as well as it has a solar controller functionality to charge a 20 amp hour lithium iron phosphate battery. They were using lead acid batteries that they had to change out every year. So they had to send technicians to sites where they couldn't run the power AC mains to. They had to run these battery backup systems that would be charged by solar. So they have these units set up, and we're working with them on additional pilots for this application. So it's an interesting application of batteries. We're going to go up to Canada right now. Let's go to Alberta, Manitoba. This is an example of some of the work that we're doing with nanometrics. This is a very interesting application for oil and gas exploration. So this is a KU band satellite-based telemetry system. So out there, there's no LTE cellular. You don't have the radio packet. The data rate's too low, so they go to satellite to get the bandwidth that's required. And you'll notice they have 4 fairly large panels. This is about 100 watt each, so you're looking at 400 watts a panel because of the short solar day, right? So up there, it's much shorter, so you have to use fairly large panels, and also it's overcast, so you have to compensate for that as well. And they use some of our 20 amp hour batteries and controller system that they built, and it's been quite interesting so far with them. This is the same concept. This is a company called Flow Services in Shreveport, Louisiana, Laredo, Texas. This is a solar-based telemetry system. This is, again, looking at oil and gas flow monitoring. This operates on LTE cellular, and they do use radio packet where places they can't get LTE cellular. They've incorporated our 20 amp hour and 30 amp hour batteries, solar controllers. They replaced the entire SLA AGM batteries with lithium iron phosphate. It's been a lot easier to maintain in terms of the cycle life and the performance. Some of the events we've been to, I think I've seen some of you at Hamvention. We've been going past several years, and there's a lot of West Coast events here where we're at, but hopefully we get to see you guys at some point in Ohio for Hamvention out there if you guys attend, coming down to visit it's going to happen next year. Some other photos of some other events we've been to as well. This is really interesting up here in the corner. You'll notice this is an example of a Go box. This is out of a Pelican case where they put the radio, put the solar controller, as well as the battery, some foam. Take that for emergency preparedness as well. So when the power fails and you want to transmit and need something, building a Go box tends to be a good activity as a club. We really recommend it. We've worked with a lot of clubs in terms of them building Go boxes as well. Same principle, you have the battery and then they choose whatever radio. And then there's some solar component as well in there if needed for charging the batteries out in the field. CQ magazine, there's been some articles written as well. Certainly take a look at that. And then at QST magazine, there was an article written about batteries. This is a really neat book. This is Stu Thomas's book about portable operating. Talks about batteries. If you want to have a chance to read that, there's some cool things in there as well. We're in other markets, audio visual, marine market. So if any of you have if you go fishing, you have trolling motors, fish finders, we're replacing the lead acid batteries that are used for that market as well, because the trolling motor batteries, the lead acid ones can't really keep up, and the fish finders are pulling a lot more power as well. So it's an interesting application. Batteries, robotics, RVs, and campers out there in the field. Some of our other products we have here, some of our power pack products, they have a built-in battery inverter, as well as solar controller. So we can use that for, in case of power failures, backup systems. We have those available as well. So now here's the door prize. This is the 12-volt 9-amp-hour battery. And then you'll get also the accompanying charger as well, power supply. So this will be the lucky winner will get this. This is good for up to 50-watt radios. It's a really popular battery. So you can use this one for that application as well. So when you guys are ready, you guys can send me the information. And we'll open it up to questions. Send it back to Mike. Want to open up any questions?
Question.
Yes, Steve, go ahead.
Yeah, I just wondered if you know of any applications where amateurs are using your products in repeater use.
Yeah, that's a great question. So we have a lot of our customers are using some of our, we're down here in Southern California, we've done the repeater installs using 100-amp lithium iron phosphate batteries. When the repeater, we've had some power outages here because of the wildfires. They've preemptively shut off the power to the repeaters. And so we did some change outs using our 100-amp lithium batteries, which 100-amp lithium is like almost 200-amp lead acid in terms of runtime, because you get that close to 100% usable capacity. And
these are running 100-watt amplifier kind of repeaters, do you know? Or?
Yeah, I think actually the repeater, the power, repeater is mostly listening on the transmit side. I think it's less than 100 watt. It's somewhere near there for VHF, UHF, and DMR. They're using, so it's analog, DMR, D-Star. Those are the ones they're running, as well as Fusion. And they're using also the Epic, this product right here with that. So they'll connect the repeater to here. They'll have the power supply over there, and they'll plug the battery in to here.
Is that your product, or is that West Mountain Radio?
Yeah, that's a West Mountain product. It's fully supports our batteries. So
you don't. I mean that thing uses diodes for sharing rather than FETs. I'm surprised that you're using that.
Yeah, this one has been used for the repeaters. It's been quite. It's worked. It's been very stable. They've done a lot of tests. In fact, when they shut off the power, it did the seamless switchover, and it's been quite good so far out here based on the current wildfire situation. There was a lot of shutdowns on mains going to the repeaters, and they've been switched over to battery for that period of time, and then it switched back once the mains was restored. We've had customers using. I have one, the Los Angeles Aries Group, which is the amateur radio emergency service. LAX Aries has their own repeaters that are separate from the ARC. So here here in Southern California, in Northern California, Aries is separate from the ARCs. I don't know about Michigan. I believe it's combined. I'm not sure. But here they've separated Aries repeaters. And the Aries repeaters, they've been able to work with the counties for budget in order to update, to either upgrade the repeaters, upgrade the batteries, upgrade the electronics and accessories around it. It's been a good cooperation because we have fires and we have quakes, so there's interruptions every so often that we have to watch out for, and so they've been able to make the change outs, and they have these lead acid batteries that they had to keep servicing every, they're going up there every year, maybe even every 6 months if I recall, to make those updates to check on the lead batteries. And the lithiums we put in 3 years ago on a couple of the different sites. We just put another in San Diego. We changed out 2 repeaters to the lithiums as well. So we're changing them out as the lead batteries, lead acid batteries. As they fail, they're just starting to change them out as well. And it's been. They said the performance has been a lot better in terms of, you're dealing with a voltage that's, 13.2 to 13.5 volts, and you get that depth of discharge requirement.
And they can be flow charged, but you require that to be current limited.
Yeah, there's a current limiting on the charging side. So the current limiting requirement for the battery is about half its capacity. So that's the maximum in terms of charge current that's going in. So if you're using a benchtop supply, if your supply, for example, if it's a very large battery, like a 100 amp hour battery, the supply is limited to 30 amps usually, roughly. So it's okay. You don't need you wouldn't need this per se. This provides additional capabilities for the smaller batteries. So for example, if you were to use a fairly large benchtop supply without the current limiting option on the supply, then you would use this. But if you have current limiting on the supply, if it's supplies that are like $100 or a little bit more expensive have some current limiting options in there. Some of them are fixed.
Our repeater, we're powering it off of a MyCore supply, which you can set the flow voltage and then you can set the current limit. I think it's set to like 30 amps.
Yeah.
Right now.
Yeah, then you
max,
should
max current. So that would be sufficient on what size battery would that work with?
So if you're going to be doing 30 amps, then the smallest battery that you could use for the repeater would be 60 amp hour. That
60 amp.
Yeah.
Or turn down that current limiting a little bit.
Yeah, turn it down a bit to meet that requirement. Now it depends on what your we have drills out here. So what ends up happening is every year they do this called shakeout drill, which is for earthquake. Every October they do it, and they will go to battery operation. So they'll do the switch over manually to batteries on the repeaters, and they'll set up. Here we have VHF, UHF. We also do HF because we have our geography. We have a lot of mountains. We're in a basin. So we have some line of sight problems. So we switch. We run an HF also in some other counties, Riverside of San Bernardino counties east of here, where they can deal with the obstructions in certain parts of the cities. So they'll do a drill every year to see how that goes. You may not need that because your repeaters, my understanding, are they on the television station towers, or where are your repeaters located typically?
Well, the South Line repeater, we actually have 2 sites. We have a water tower site, okay, and we also have a private residence. A guy with a tall tower. Currently, we're at the private residence, and as I say, we have battery backup, but it's one of those cylindrical wound lead acids, or it kind of got over discharged and it's not working so swell anymore. So yeah. I think we're going to be looking for a replacement. Is all your solar stuff?
Can somebody else ask a question, Steve?
Absolutely.
Yeah. Okay, good.
Go ahead. I'll ask mine later.
Could I ask a question?
Sure, yeah.
We can interrupt this and you can jump in.
Yeah. I noticed with interest that you are also making batteries for the UPS industry. So are these batteries plug replaceable like in APC UPSs?
Yeah, we have the it looks something like this where they have the tabs on top. So the circuit board, let me go back just a second.
Well, the reason I'm asking the question is to get to Steve's point about the current limiting. I don't know anything about the characteristics of the APC UPSs and what they do as far as current limiting.
Yeah, the APCs have a charge current that's quite low. So what ends up happening is the circuit board in our 12 volt 9 amp hour and 12 volt 12 amp hour has enough in terms of the threshold for charge current. It's fully compatible in that regard. So most of the APC and triplet units, from what we've seen, is fully compatible with the 9 amp hour and 12 amp hour batteries. So it's a drop-in replacement, no issues.
Oh, cool. Thank you.
Do you have motorcycle applications also?
Yeah, we have a starter battery. It's called the BLP series. So for we can do right now up to 1,000 cold cranking amps. We just introduced it. So we have from 100, 200, 300, 600 CCA, and then up to 1,000 CCA for lithium iron phosphate. And it's in a cylindrical package, so they don't. They're like this.
One other question I have, with a duty cycle of about 45 amps for a very short period of time, I can talk to you about it offline. It's another application that you might be interested in outside of the list that you had there. So that I'd be interested in trying to apply to my own setup. So
sure.
Was your number on that card, or is there a way to get hold of you outside of this meeting?
Yeah, so this is on the beginning of the presentation here. I'll paste it into the chat as well, my information. Make sure that's in there as well. So let me just go to full screen.
Kevin, one thing you did not mention was the fact that West Mountain Epic is also good for solar charging.
That's correct.
There's a terminal on it, hook right to your solar cell.
Yeah.
Use that for field day. It works great. Use it for field day with one of your batteries. It works fabulous.
Yeah, that's a good point. This has a solar panel input up to 50 volts open circuit, so you can use this for that application as well. So we've been working with a lot of partners for accessory products like this in order to charge the batteries and use your existing, charging systems, etc.
Yeah, it's really good.
Kevin?
Go ahead.
I spoke first. Kevin, what about mobile rigs, 2 meter 440? Typically, they take 4 to 6 amps at 13.8 volts. How are they going to run at just 12 volts?
So these actually sit at 13.2 volts. So we say 12 volt nominal, but the operating voltage is 13.2 to 13.5 volts. Let me just let's see if I go to that screen. It's right. It should be right here.
Yep. It was there.
Yep. I think it was here. Here it is. Yeah. So we're good on the operating voltage term for radio.
Okay.
Kevin, is there any low temperature charge protection? If it gets too cold, will the PCB not allow it to charge?
It's a good question. So that goes back to the temperature profile here. So the circuit board on the low end, what ends up happening is if you were less than -20 Celsius, less than 14 Fahrenheit, if you were to use the battery at that temperature, as you go lower and lower, the capacity is not fully available because the rate of the reaction that's taking place in the cells, it slows way down. So you don't get the 100% usable capacity. It starts to trail off to less than 80%. It doesn't get damaged. There's no damage to the cell. It's just what's usable drops off. So what ends up happening at very low temperatures is some customers have to increase the capacity of the battery. So we've seen this with certain things for oil and gas industry, where they were compensating for the really cold temperatures because they wanted to run some equipment for a longer period of time. So if there's something where you need to run, as the winter comes over there, you may have to increase the size of the battery to make up for the diminished runtime that happens at really cold temperatures. So, are you planning something in the winter? Really,
winter field day, man.
Yeah,
but
that's right.
I'm more asking if the battery gets too cold.
Yeah.
Is there any risk or any protection from charging it at say it's just 0 degrees out, right? Am I going to hurt that battery if it's that cold by charging it, or is there any protection circuitry to prevent that?
I thought you said discharge. Okay, so for charging, it's the battery will take the charge current, but because it's so cold, the rate of increase of the voltage will be much slower. Okay, so it's not as fast as what you would see at warmer temperatures above 0 Celsius, above 32. So if you're less than 32, yes, the battery will take the charge current going in, but it will take longer to increase the voltage of the battery to get to full charge. So if you're less than freezing, it's going to take longer to charge the battery.
But you haven't experienced any damage to the cells doing that?
I have not, no.
Okay.
This chemistry is really robust. It's a lot different than the polymer stack in the phones.
Yeah.
The polymer stack in the phones, the issue with that is there's this electrolyte layer that's really thin. There's a stack of cathode and anode stack in there, and then there's as the temperatures vary a bit, we've seen issues on the on the phone batteries. If you put in really cold temperatures, you get some mechanical integrity issues inside of the pack because of some exposure. Maybe some portion froze, some portion is warm, and then you get something that happens to the cell, and they get outgassing problems on the polymer stack. But because we package it like this, a spiral wound cylindrical cells, this package is superior. This is what they're using in electric vehicles, right? So same type of package. That's what I really want to emphasize, that fact. This is the chemistry that we've selected can do that low temperature performance, if not even better than what's on the market for that. So
cool. Thank you.
Yep.
Hey, Captain. Mike, I got a question. If I'm going to fly and I wanted to take my radio with me, do you know what the largest battery that I could take with me according to TSA?
Yeah, so right now it's limited to 160 watt hours, which is 12 volt, 12 amp hours, which is 144 watt hours, which is less than the 160. So 12 volt, 12 amp hour at this time is the largest you can carry on. However, there was a petition that was filed by the battery industry, and they're going to be expanding the watt hours. And from what I'm hearing, it might be going around 300. So this is a good news because there's a lot of electric wheelchairs, a bunch of stuff that uses batteries, and we're waiting for that to trickle through FAA, and there's one of the DOT. There's two agencies that are going to be making the change. I don't know if it's going to be upcoming calendar year. It might have been. It's going to happen. I just don't know when, what date. But right now it's 160 is the max. That's for domestic. Now for international, it's a little bit less. If you're going fly international, including Canada, Mexico, it's 100. Okay, so you can only get the 12 volt, 8 amp hour batteries. So I don't know if the international restriction is going to expand. The domestic will expand. So.
Thanks.
Are there any mechanical lithium polymer batteries are very susceptible to catching fire if they're mechanically damaged?
Yeah.
Is there any problem like that with this technology?
This is what's different. So we have the lithium iron phosphate, the chemistry, the iron phosphate bond is very, very tight, unlike a polymer battery, which uses something called lithium cobalt oxide. So you have something where it's oxide radicals can cause that on the polymer stack, whereas this one is different. If you go on YouTube, you can see them put a nail through this type of cell, it don't catch fire. So that's what's really nice about this chemistry. Unlike the lithium polymer based on cobalt oxide mixes, the iron phosphate bond's very, very tight, which is why we chose it as a company. And it's a lot of videos and if you go read online, you can go check it out. They've shown that it's, from that standpoint, it's a lot safer.
Isn't one of the reasons people go with lithium ion is that there's more charge in the same size package, so you don't get as much charge in a physical size, but you have the safety that's the upside. Is that correct?
Yeah. So we're gonna when I said lithium iron, IRON phosphate. So
right.
Yeah, lithium iron phosphate. You get the higher cycles. The energy density is less than what's in the other chemistry, the lithium cobalt oxide or other mixes, but you get a battery that has the high degree of thermal stability and chemical stability.
I understand. That's what I thought. I wanted to make sure.
Yep.
Question on, say, putting the battery more full-time in a vehicle. One thought was to have it power the radios in my vehicle rather than my vehicle pulling directly from the starter battery. How significant do you reduce the life and performance of the battery if it's in a vehicle full-time with the thermal cycles through the year?
So the usable capacity is only affected in that regard. So we're looking at this chart again on the usable capacity at near, let's say you're at 14 Fahrenheit. But that's, if the car warms up, you turn on the heater inside the vehicle, the battery's in the back seat. I'm not sure where you're going to be putting in the vehicle. I don't really, if you're getting something that's room temperature, you're still getting all the available capacity to you. It's just if you're going to be storing the battery, let's say in the trunk or something, then you're going to be subject to frozen temperatures, and not all that capacity is usable. Maybe about 85% usable. So it depends on where you place it. So from what I've seen, most people are putting it in the front or back seat. So you turn on the car warms up. You come back to the car. I don't know if you have a remote start for the vehicle. You're going to be able to use all the capacity from the battery without any issues once you get to that temperature, regular room temperature setting in your car.
Cool, thanks.
Yep.
I've got another question.
Sure.
Okay, so say you have a car that doesn't have a very powerful 12-volt battery. It's there for just minor appliances, and that couldn't handle the draw of a regular radio. 2M440, but could you use it to charge? So my idea is I hook the radio up to the Bioenno Power and work it from that, and then let it recharge from the 12-volt over time when I'm not using the radio. Is that a reasonable way to do it?
Yes, we just introduced a new product that allows you to charge the battery from the car. So it's a DC to DC charger. It's on our website under the chargers section. It's brand new. It allows you to charge the battery at 3 amps. You can then you can charge the battery while operating from the radio, and you can pull the max current. So let's say you can hook up that car charger, you plug in the cigarette lighter, it will plug in here, and then you just plug this into the radio, and you can get all 23 amps out of the battery to run the radio while the vehicle then charges the battery, which is going to happen on receive because you're not pulling out of the battery, and it works seamlessly. It's on our website under the battery charger section. A new product that was just introduced actually a few months ago. We were going to debut it at Hamvention, but we had to do it earlier this year. We have a lot of new products that were introduced this year on the website. We got new solar panels, these foldable panels. We have the car charger accessory. So we have a lot of accessories this year that we introduced. Certainly check it out.
Sounds like it's going to be perfect for what I want to do. Thanks.
Yep. Any other questions?
Well, with no other questions, I'm going to say
Thank you.
good presentation. Thank you very much.
Thank you very much.
Kevin.
All right, and also, Mike, if you don't mind, or whoever's going to send it to me, the winner, whoever
Yeah.
that winner is, just email it to me, and I'll have it shipped out on Monday.
I thought we'd do that right now. I just wanted to make sure everything was done.
Okay.
I'm going to pull up. So are you finished?
I'm done. Yep.
Okay. I need to share.
Let me
the
stop
app.
my sharing. Yep.
Okay. And, oh, I better bring it up. Let's see. Go here. And I have it saved so it's easy to find. Okay, now I want to share this. So I go back to this, share screen, and it's this one. And share. Everybody see this?
Yep.
Okay,
Got it.
so
Yep.
I can say from 1 to how many do we have? 18.
18.
So I go from 1 to 18 and I start it, and it's whenever I stop it, it'll be the number. Number 16 wins it. Who's 16?
Well, that's me.
Rigged. Totally rigged.
Rigged.
Hey, watch. See?
We want a recount.
I'll let. I was worried about that. I'll let it go.
No.
Jimmy Jerry.
It was. If it was me, that would be one thing. But it was on my computer. See, this is a great app that I found today that works really nice. You can put in the numbers between 1 and 18 or 1 and 40, 47, whatever, and you start and stop. And when you stop it, that's whatever the random is. It's pretty cool.
Congratulations, Jerry.
Well, thank you. It's very generous store price. Thank you to Bioenno for that. That's wonderful.
Now, how do I? Oh, I stop it up here. Stop, share, bada boom, bada bing. I'm learning. Even an old dog can learn new tricks.
Yeah, I'll go ahead and stop recording, I guess.
Well, Kevin, very good presentation. Very